question concerns the interpretation of the National Electrical Code, specifically Table 300.5 and Section 680.10, as they relate to residential branch circuits and the installation of electrical equipment near swimming pools. The query revolves around whether the cover depth requirements of Table 300.5 apply to the exception outlined in Section 680.10 concerning residential branch circuits. The answer clarifies that the interpretation presented in the question is incorrect. Section 680.10 deals with the requirements for electrical equipment in the pool area and generally mandates that such equipment be located at least 5 feet away from the inside walls of the pool. However, an exception exists within Section 680.10, specifically exception number 1, which addresses residential branch circuits. This exception states that when electrical equipment is installed on a residential branch circuit, it must be located no less than 18 inches from the inside walls of the pool. It's crucial to understand that Table 300.5 is not referenced in Section 680.10 exception number 1. Therefore, the burial depth requirements outlined in Table 300.5 do not apply to the installation requirement specified in Section 680.10 exception number 1. In conclusion, Section 680.10 exception number 1 takes precedence for residential branch circuits and its requirements must be adhered to, irrespective of the cover depth considerations found in Table 300.5. To elaborate further, let's dissect the components involved in this code interpretation. Firstly, consider the purpose of Table 300.5. This table provides minimum cover requirements for direct buried cables, conduits, and raceways. The depth of burial is determined by several factors, including voltage, location, and whether the wiring is under a building or concrete slab. Its primary goal is to protect underground wiring from physical damage, such as that caused by digging or other ground disturbances. Next, examine Section 680.10, which pertains specifically to swimming pools. This section aims to ensure electrical safety around pools, recognizing the increased risk of electric shock due to the presence of water. The general rule in Section 680.10 mandates a 5-foot setback for electrical equipment from the pool's inside walls. This setback is intended to minimize the likelihood of someone in the pool coming into contact with the electrical equipment. However, exception number 1 to Section 680.10 provides a more lenient allowance for residential branch circuits. This exception permits electrical equipment on a residential branch circuit to be installed as close as 18 inches to the pool's inside walls. This allowance recognizes the lower voltage and amperage of residential circuits, as well as the fact that residential pools are typically smaller and less crowded than commercial pools. The critical point to grasp is that exception number 1 does not reference Table 300.5. This omission is intentional. The code-making panel recognizes that the primary concern in the pool area is preventing direct contact with electrical equipment, not necessarily protecting buried wiring from physical damage. The 18-inch setback provided by exception number 1 is deemed sufficient to address the risk of direct contact in residential settings. Therefore, the cover depth requirements of Table 300.5 are relevant when applying Section 680.10 exception number 1. The wiring must still be installed in accordance with other applicable code requirements, such as those related to wiring methods and grounding, but the specific burial depths outlined in Table 300.5 do not govern the installation. To illustrate this further, consider a scenario where a 120-volt residential branch circuit is being installed to supply power to a pool pump. According to Table 300.5, a 120-volt circuit typically requires a minimum cover depth of 12 inches. However, because the circuit is governed by Section 680.10 exception number 1, the 12-inch cover depth requirement does not apply. Instead, the circuit can be installed as close as 18 inches to the pool's inside walls, regardless of the actual burial depth. This does not mean that the wiring can be haphazardly installed. It must still be protected from physical damage, but the specific depth requirements of Table 300.5 do not apply. The installer might choose to use rigid metal conduit or intermediate metal conduit for additional protection, or they might opt to bury the wiring deeper than necessary, but these decisions are not dictated by Table 300.5. They are based on other factors such as soil conditions, local regulations, and the installer's professional judgment. It is also important to note that other exceptions and requirements within Section 680 might still apply. For example, Section 680.21 specifies the types of wiring methods that are permitted in the vicinity of a pool. Additionally, Section 680.26 outlines the requirements for bonding metal parts of the pool and its associated equipment. These requirements are intended to create an equipotential plane around the pool, which reduces the risk of electric shock. Therefore, while Table 300.5 does not apply to Section 680.10 exception number 1, other code requirements must still be followed to ensure a safe and compliant installation. In summary, the interpretation presented in the question is incorrect because it conflates the cover depth requirements of Table 300.5 with the setback requirements of Section 680.10 exception number 1. Table 300.5 does not apply to exception number 1, and the 18-inch setback is the governing requirement for residential branch circuits. It is vital for electrical professionals to understand these distinctions to ensure safe and compliant installations around swimming pools. To further enhance understanding, it's beneficial to explore the historical context and rationale behind these code provisions. The National Electrical Code is not a static document. It is constantly evolving to reflect new technologies, installation practices, and safety concerns. The code-making process involves extensive input from industry experts, including electrical engineers, contractors, inspectors, and manufacturers. These experts review incident data, conduct research, and debate the merits of proposed code changes. The ultimate goal is to create a code that is both practical and safe. The provisions related to swimming pools have been the subject of considerable scrutiny over the years. The code-making panel recognizes the unique hazards associated with electricity and water, and they have continuously refined the requirements to minimize the risk of electric shock. The 5-foot setback requirement in Section 680.10 is a product of this ongoing refinement. It represents a consensus view among experts that this distance is sufficient to prevent direct contact with electrical equipment in most situations. However, the panel also recognizes that a blanket 5-foot setback requirement might be overly restrictive in residential settings. Residential pools are typically smaller and less heavily used than commercial pools. Additionally, residential electrical systems are generally lower voltage and amperage than commercial systems. For these reasons, the panel created exception number 1 to Section 680.10, which allows for a reduced setback of 18 inches for residential branch circuits. This exception strikes a balance between safety and practicality, allowing homeowners to enjoy their pools without unduly restricting the placement of electrical equipment. The decision not to include a reference to Table 300.5 in exception number 1 was also a deliberate one. The panel recognized that the primary concern in the pool area is preventing direct contact with electrical equipment, not necessarily protecting buried wiring from physical damage. The 18-inch setback is deemed sufficient to address the risk of direct contact in residential settings, and the cover depth requirements of Table 300.5 are therefore deemed irrelevant. It's important to remember that the National Electrical Code is a minimum standard. Electrical professionals are always free to exceed the code requirements if they believe it is necessary to enhance safety or improve the quality of the installation. For example, an installer might choose to use a heavier gauge wire than required by the code, or they might opt to bury the wiring deeper than necessary. These decisions are based on the installer's professional judgment and their assessment of the specific circumstances of the installation. The National Electrical Code is not intended to stifle innovation or discourage best practices. It is simply intended to provide a baseline level of safety that all electrical installations must meet. In addition to understanding the specific code provisions related to swimming pools, it's also important to have a general understanding of electrical safety principles. Electricity always seeks the path of least resistance, and water is an excellent conductor of electricity. This means that even a small amount of electricity can be dangerous in a wet environment. To protect against electric shock, it's essential to use ground fault circuit interrupters, or GFCIs, on all circuits serving the pool area. A GFCI is a device that monitors the current flowing through a circuit and quickly interrupts the power if it detects a ground fault. A ground fault occurs when electricity deviates from its intended path and flows through an unintended conductor, such as a person. GFCIs are incredibly sensitive and can detect ground faults that are too small to be noticed by a person. They can trip a circuit in as little as 1/40th of a second, which is fast enough to prevent serious injury. The National Electrical Code requires GFCIs to be installed on all circuits serving swimming pools, hot tubs, and spas. It's also a good idea to install GFCIs in other areas where water is present, such as bathrooms and kitchens. Another important safety precaution is to ensure that all metal parts of the pool and its associated equipment are properly bonded. Bonding involves connecting all metal parts together with a conductor, which creates an equipotential plane. An equipotential plane is an area where all metal parts are at the same electrical potential. This reduces the risk of electric shock by preventing voltage differences from developing between different metal parts. The National Electrical Code outlines specific requirements for bonding swimming pools, and it's essential to follow these requirements carefully. In addition to GFCIs and bonding, it's also important to maintain a safe distance from overhead power lines. Power lines can carry thousands of volts of electricity, and contact with a power line can be fatal. Always be aware of the location of overhead power lines when working near a pool, and never allow ladders, poles, or other objects to come into contact with the lines. Swimming pools can be a source of great enjoyment, but they can also be dangerous if not properly installed and maintained. By following the requirements of the National Electrical Code and adhering to basic electrical safety principles, it's possible to create a safe and enjoyable pool environment. In conclusion, the correct interpretation of Section 680.10 exception number 1 is that it supersedes the burial depth requirements of Table 300.5 for residential branch circuits. The 18-inch setback from the pool's inside walls is the governing requirement, and other applicable code provisions must still be followed to ensure a safe and compliant installation. Staying informed about code changes and best practices is crucial for electrical professionals to ensure the safety of themselves and their customers. Remember, the National Electrical Code is a living document, and it's important to stay up to date on the latest revisions. Attending continuing education courses and participating in industry events are excellent ways to stay informed and enhance your knowledge. By working together, we can create a safer electrical environment for everyone.